Hello, I'm Mark Pettit. I'm a BIM technical consultant here at Man & Machine. And in this session, we're going to look at Revit MEP and the functionality that the software gives us for us to design our project work straight into the software. So Revit MEP is a data-enriched modeling software where we can create a lot of project work very quickly based on a 3D sort of model environment. And that enables us to share our information between all the different project team members, whether it be a structural engineer, an MEP engineer, or an architect. And we're all using the same data-enriched modeling environment. We're feeding off each other's data to create our own project work in our projects. Sorry for the we've had some technical difficulties this morning with our studio. So this is a Zoom communication rather than using our studio. So forgive me if we're swapping between screens and it's a bit disjointed, but we'll see how it goes. Okay, so as I said, we're going to be looking at Revit MEP with a focus on our ventilation systems and using the functionality the software provides us to create those systems very quickly in our 3D environment. So I mentioned the word in sort of enriched data. What do I mean by data? So if we look at a drawing in AutoCAD, we can see we have a very simple ventilation system here. It's a simple 2D CAD package. So in this example, it's AutoCAD. And we have some ductwork systems, supply and return with a ventilation unit. We have some air terminals, some very basic classroom environments. And as we can see, sorry, I've just been told I'm not screen sharing. 2 seconds. Sorry, we're having technical difficulties this morning. And we are now screen sharing. Yes, here we go, sorry. So here we are. We have our AutoCAD drawing, our 2D drawing showing some ductwork and some air terminals in some classrooms. And traditionally, a designer would create the designs with some sketches. They would use a calculation package or a ductulator to work out their duct sizes. Here you can see we have some ventilation rates, some airflow rates, some velocities and sizes. These are just text items in our CAD environment. And the ductwork is made up of lines. So if we wanted to add another grill into this classroom, as a designer, you would look at your airflow rates. You would add another grill perhaps here. You would grab your line work from over here. You would then copy that line work and place somewhere over here where you'd like your grill. And you would then copy the associated text that goes along with that grill. But what you can see now is we have 80 litres a second. We have 4 grills now at 80 litres a second, so that's 320. But as you can see, we still have 240 litres a second in our duct here. So we'd have to go in here and actually edit that manually. Type in 320 and then follow this round. We have 320 plus 160, giving us 480. And as you can see, it's a very manual process, taking us back to our ventilation unit here. And again, using a ductulator or a calculation package or even an Excel spreadsheet, with values added, we'd have to go around and check these duct sizes and these velocities on our ducts and alter the size accordingly. And if we needed to alter the size of the duct, we'd have to move our line work to suit the new size of whatever that duct's going to be. So a very manual process. If you imagine you've got to do that throughout the whole project, it's very time consuming, very inefficient. And a lot of work to change from simple settings. If we look at the same drawing but over in the Revit environment. So exactly the same drawing, exactly the same classrooms. And now you can start to see some of the ductwork is colored up. So the blue ductwork is supply ductwork, the magenta is return ductwork. And we have our same supply air diffuser here, S1, 80 litres a second. You can see that space there where we copied the grill over in the AutoCAD environment, and you can see those same bits of metadata here attached to the ductwork. So what I'm going to do, I'm just going to grab this grill. I'm going to copy that grill to somewhere there. I'm going to ignore the error about hosting on a surface for now. And you can see we've got a grill, nothing else attached to it. But what I can do here is, using the functionality of the software, I can connect that grill straight into this supply duct. So it's selecting the grill, connecting to my supply duct. And as you can see, it's ducted up my supply air grill, added it to my supply run here, and also it's updated the flow figure in my main duct here, 320, and you can see here it's updated my grill, my flow rate in my supply duct here to 480. So it's added those volumes together automatically. So just to show that again, if I take that grill away, you can see the flow rate changes automatically. So it's in the background as a database of information that is constantly updating as we create our design. And rather than having text, we have tags. So these report on various information within whichever object they are tagged to. So here we have a duct tag reporting on the size, flow rate, and the velocity. Over on the left here, we have another tag reporting from this return air diffuser, the diffuser name or type, and a flow rate at the diffuser. So if I were to tag this grill here, so let's create similar, you can see it's picking up similar information. We have an S1 type grill, and we have 80 litres a second. If I select grill, I mentioned data enriched objects earlier. If we scroll down our properties list on the left here, you can start to see where that data sits. So we have our flow rate of 80 litres a second. We have a pressure drop on the grill of 64 pascals, and so on. Various other items here. We can see what supply system it's on. So it's on supply air, called mechanical supply air 2. We have a size of 150, which is the connector size, and so on. If I was to change flow rate in my properties over here, so let's change that to 40. There we go, 40. You can see the information being reported from the air terminal. It's 40 litres a second. And our properties of our ductwork changes here to 280, and then further on down the line, 440. So as we change through our system, it's all linked together. It's creating a closed system, and all that metadata is working with each other all the way through our system and helping us to develop our designs straight into software. And because it's designing straight into the software, our drawings are updating automatically as well. So that's a very quick comparison between 2D CAD, where we have lines and text based on a very manual design process, into our Revit environment, where we have a very sort of data-rich, object-enabled environment, where everything is designing all in one go, and very efficient, very quick way of creating project work. So what I'm going to do now, I'm going to close this, and I'm going to create a brand new project. I'm going to use a template, a mechanical template. So these templates, they're all roughly the same. All these are creating various views depending on the template you're creating from. So a mechanical template will create some mechanical views. an architectural template will create some architectural views. But in the background, a lot of the settings are pretty much the same. And this is where you would store your corporate template if you were creating some project settings that you wanted to use over and over again through your project work. And you can drive consistency through your projects in your particular company. So I'm going to choose mechanical template. And what I'm going to do, I'm going to use a completely blank Revit 2023 project template, and I'm going to create a project. I'm going to link in an architectural model, and then I'm going to create some MEP spaces, and then from there I'm going to create some design criteria, and then I'm going to create some supply and return ventilation systems. Okay, so this is all out of the box Revit. There's no sort of pre-setup. I'm just using everything straight from Autodesk. You could actually have sort of a company standard families and templates, but this is all completely out of the box to show you how easy the software is to use and to start using. So the first thing I need to do, I need to have a building to base my MEP project on. So this is typically an architectural model. And this is where you have that collaboration between your project team members. The architect will develop their building. The structural engineer will develop their structural model to help support the fabric of the building. And then the MEP engineer or MEP designers create the systems within the building for the heating, the ventilation, the lighting, the power, etc., etc. So I'm going to go ahead and insert a link. So I'm going to link in my architectural model. And here I have an example of architectural model. If you followed our previous webinars, you might recognize this model. It's been used in a few webinars in the past. I've just taken the same model to use in this example, and it'll be developed up in future webinars as well. So here we have positioning. We can either center to center, origin to origin, so 0, 0 to 0, 0, or if there's a shared coordinate system, we can use a shared coordinate system that's been defined on the project. And this pins your project files in the same place throughout your project team. So then when you share your information and you place, for example, your MEP project work into your architectural project work, they'll come into the same place. It pins it in an X, Y, and Z position to real world coordinates. And this helps if you're also exporting to an open bin format, such as IFC. It will pin your project in exactly the same place for the whole of your project team. So things like Navisworks, if you're going to up to the cloud using Autodesk Construction Cloud, it makes sure all your models are in the same place. Okay, so just for this example, I'm just going to use center to center. I'm not going to be sharing this project. It's just purely for this session today. As you can see, it brings in the architectural model, the center point of the model, sort of roughly in the middle to the center point of my MEP project environment here. So the first thing I'm going to do is I don't need all these trees and everything around it, all the cars in the car park. I'm going to create a scope box just around my building. So I'm going to go to View, Scope Box, and I'm going to draw a scope box around my building. And I'm going to call it building. Very simple. So now any future views, I can use that scope box to focus down onto the building that I'm trying to use. So this mechanical view, for example, here, I can now scroll down and I can choose scope box called building. And as you can see, it filters down. Everything else around it disappears. And now I've got a nice clean building to look at here. Okay, I'm going to turn my crop region off so the scope box disappears. We've got some people here, we've got some furniture, etc., etc. I'll ignore those for now. First thing I need to do is I need to align my project levels and my grid lines to this architectural model. So first of all, I'm going to do grid lines. I'm going to go up to my Collaborate ribbon, and I'm going to use my Copy Monitor tool. I'm going to select my link, and I'm going to copy these grid lines. And I can't seem to select the grid lines. Copy monitor. Why is that then? Let's finish that command. Let's go down here, look at a few set underway items. Let's turn all these off. Let's try that again. So copy monitor, select link, select my link. Let's copy. Here we go. So there's 1, there's 2, there's 3. For some reason, the scope box is clipping off the grid lines outside. I can't select the grid line for some reason. I'm within the scope box here. So I've selected all those grid lines. I now want to monitor those grid lines. So what we're doing here is we're copying the grid lines and placing that instance of those grid lines in our project file, in our MEP project. And we're now going to monitor those positions against the grid lines in the architectural model. So if the architectural model, if the architect moves those grid lines, or if the structural engineer moves his grid lines, Revit will look at those grid line positions and check when you load up your project to make sure your grid lines are in the same place. And it will give you a warning. It won't actually move your grid lines. It will just warn you that the grid lines have changed and you need to take a look and you need to check, see what's going on between your models. So now I'm going to monitor. So in the bottom left-hand corner, it's asking us pick an element to monitor. So I'm going to monitor the grid line, and I'm going to choose corresponding grid line, saying it's already monitored. And as you can see here, we have a little symbol. And actually doing the copy command has actually started the monitoring for us already. So you can see we have our monitor icon on our grid lines already. So what I would do now is I would select all my grid lines and I will pin those in place. So they're now pinned and they are based on the architectural model. What I will do now is I will create some project levels in my MEP project. And again, the same as the grid lines, I'm going to use the architectural model as a base. And the architectural model will have 5 or 6 levels going up the building. I will copy those level positions and I will monitor them and then I'll pin them in place on my project. So this ensures then when I share my project work with the architect or with any other project team members, that information is pinned in the same place based on those data, those levels. So those levels define whereabouts your project work sits within your project model. So obviously we want our floor levels to be the same as everybody else's floor levels, otherwise it'll create confusion across the project. So what I need to do, I need to go into an elevation. So let's just go into one of these elevations, let's go into north elevation. And you can see we have our architectural model in the background here. And you can see we have our levels in our architectural model, and we have our levels 0 and 1 in our MEP model here. So when you create an MEP model from scratch, it puts in a couple of levels for you to start from. Okay. I've got lots of other information going on. I've got trees and all sorts. Let's go into my visibility graphics. I'm going to turn off trees and things outside. So planting, let's turn the parking off, planting. So clean up our model a little bit better there. So first of all, we have a level 0 and level 1 already in our project. So going up to copy monitor, we would select our link, and then we would monitor our level 0 with level 0 from the linked model. As you can see there, we have our little link symbol. Let's do the same with level 1 and level 1 from the architectural model. Now those are linked. We haven't got a level 2, 3, 4 in our project model here, so we need to copy those from the architectural model. So let's copy level 2, and you can see the monitor symbol has already appeared. Level 3, let's go up to roof. We don't really need the parapet level. We won't be hosting any information from that level. You can copy that level across if you'd like to, but in this example, I'm not going to do that. I'm just going to leave it as is, and I'm going to finish that command. So now we have grid lines, we have our project levels, and I'm going to go ahead and I'm going to pin those levels in place in my project. Okay, so now we have our linked model, we have our project levels created, and we have our project grids created in the MEP project. So these are separate from the levels and grids in our architecture model. Okay, so that's important to understand. What as an MEP designer you would do now is you would create something called MEP spaces. So MEP spaces, they define various areas in your project for Revit to understand what's going on in those areas. So I'll go through the process and explain what's going on as I'm doing those. So what I'm going to do, I'm going to create a completely new floor plan. I'm just going to rename this 0 spaces. I'm going to change the discipline to coordination, and I'm going to change the subdiscipline to spaces. So this is just moving the view around within your project browser. So as you can see now, if I hit apply, that 0. Oh, I haven't changed there, has it? Change that again, spaces. There we go. So under coordination, under here, under project browser, you can see we have spaces, 0 spaces. So I've duplicated a level 0 floor plan, renamed it to spaces, and just moved it around in our project browser. So for our spaces, we don't really need things like furniture and things like that on there. So I'm going to turn my furniture off. Maybe generic models. Sometimes entourage is turned on with the people. What else we've got here? This is a planting. So let's go into our visibility graphics again. Let's turn off planting. And now we have a fairly clean floor plan. Okay. What I'm also going to do is I'm going to duplicate this view again. And this time I'm going to call this rooms. And the reason for this is your MEP spaces are based on either just the geometry, and then you would create your room names and numbers yourself, or you could actually feed off of the architectural model. So this is the collaboration part again, where you're feeding off data from another project team's model. So in this case, we're going to be feeding off the rooms that are defined in the architectural model. So if I go into visibility graphics in my rooms floor plan, if I go down to rooms, and there are 3 or 4, well, 3 subsettings under the rooms category. I hit OK. You can now see these blue shaded areas, and each blue shaded area is defining a room in the architectural model. So this one here, it's on level 0, looking in our properties. It's got a limit offset of 4 meters, so at the top of the volume of the room. You have an area, a perimeter, and here we have a name and a number, lobby 107. Okay, and if I tag this room, so let's annotate, let's tag by category. Let's see if this works. Okay, I've got no tags for rooms. Let's try again. Tag all. Let's see what room tags we have loaded in here. We have room tags there. Room tag with area, with volume. Let's just do a basic room tag, and we want to tag a linked model because the rooms exist in our linked model. And here you can see those tags appearing. So this is lobby 107, and that corresponds with what we see in the property. So lobby 107. Okay, so architectural rooms are coloured in a light blue colour. If I go to my spaces floor plan, what I'm going to do here now is I'm going to use analyze, and I'm going to create a space. And as I move my cursor across the screen, you can see it's waiting for the geometry to form around where that space is going to be placed. At the moment, if I click the space, it's saying space is not in a properly enclosed region. Okay, this is because the linked model, if I go into my edit type properties, you need to set your model to room bounding. Okay, this is very important. This then creates the geometry through the link for your MEP space to then take hold of what's going on. And as you can see, that space now is it's flooded that area, and it's used the walls, the floor and the ceiling, and a separation line to create the bounding elements of your MEP space. I'm just going to go down to spaces in visibility graphics. And I'm going to do the same as I did with rooms. I'm going to turn the fill on. And here you can see now we have a green area showing us there's the sort of defining MEP volume of the area. Now I click on the space. If you go down your properties list, you can see a lot more information, a lot more metadata attached to that space. So here we have some lighting calculation data fields. We've got ceiling, wall, and floor reflectance values. We have some design loads for electrical. We have our dimensions, so the same as the architectural room. We have area, perimeter, unbounded height. We have a volume, and then we have some flow values for mechanical flows. We have a specified supply airflow, calculated airflow, return airflow, etc., etc., etc. And what we can do here is we can actually choose what this space is. So first of all, I'm going to add some more spaces around this floor plan. You can actually go around and do this manually. So we have some stairs here, we have some rooms here, and we have a sort of an open space here. Or you can place spaces automatically. So if I choose space, I can choose to place spaces automatically, and I can choose to tag them when those spaces are created. So the tag is the little descriptive piece of information here. It says space and it says number 1. So let's place spaces automatically, hit close, and it's added those other 5 spaces, and it's added a tag on those, and it's numbered them 2, 3, 4, 5, 6. We don't want those to be named like that. We want them to be named to the same names as the architectural model. So here you can see stairwell, admin, reception, office, lounge, etc. Going back to my spaces floor plan, I can actually rename those according to the rooms in the architectural model. So we're going to use names and numbers. You could actually choose more levels and actually do a whole project. But for this example, I'm just going to choose all levels and apply for those 6 spaces. And you can see now our space names match our room names. Okay, I'm going to do another floor plan. So let's create a new floor plan, and I'm going to choose level 2, level 1, and I'm going to copy these 2 views. Actually, no, I'm going to rename these views. So that's 1 spaces. Two spaces. So let's rename that 2 spaces. So that's level 1 and level 2 spaces. I don't want to rename the corresponding levels. And what I'm going to do, I'm going to go to my spaces view, and I've created some settings here to show the spaces and all the other information being turned off. I'm going to create a quick template from that view. So let's go to create view template from view, and I'm just simply going to call it spaces. Okay. So now if I select those 2 new views, I can then change that template spaces, and it will put them in the right place in my project browser, and it'll turn everything off in the views. So now let's just add some more spaces in here. So space, place automatically, and you can see they've been placed automatically. Let's go to level 2, do exactly the same thing. So there's some more spaces, and here you can see space naming hasn't picked up the architectural names yet. So let's go to space naming, and let's choose those other 2 levels, 1 and 2. Okay, that. Now we have our spaces on levels 1 and 2, and they now relate or correspond with the same room names from the architectural model. Okay, I haven't saved this project yet, so I'm going to save this project. I'm going to go choose that file name, and I'm going to go into my MEP folder, and I'm going to change my discipline to M for mechanical, and I'm going to save the file. Okay, so now we've created our base project with a linked model and some defining spaces throughout our model. What we do now is we would create a schedule. I'm going to create a space schedule. So this enables me to see all my information on my spaces. So let's go down to spaces. This is the category I want to schedule on. I'm just going to call it space schedule. I'm going to hit OK. And what I'm going to do here is I'm going to find name, number. I'm also going to choose level. And I'm going to choose space type. And I'm going to choose a volume, maybe. As you can see, there's lots and lots of information we can choose here. I'm looking for design, heating load. I'm looking for flow, airflow rate. Where can I find that? Outdoor airflow, sensible, specified supply airflow, and specified return airflow. And then at the top here, we have actual supply airflow and actual return airflow. Let's just move these up and down so they're next to each other. So we have specified supply, specified return, actual return. And the reason for this is we can see now the names of our spaces, the number of those spaces, those levels that those spaces are on. We have a space type category. We have the volumes, and we have some zeros across the specified and the actual on the supply and the return. I'll look at those in a second. What we can do now is we can look at the space types for all of our spaces. Okay, so when I go back to my plan, let's go back to our 0 spaces. If I choose a space, so let's choose this one here, for example, it's an office. It's a square office. It has a volume of 60.5 meters cubed. And there are some empty data here. We have no data specified for supply or return air, for example. There aren't any cooling loads. So what we can do here, we can populate these fields very quickly by choosing a space type and a condition type. So we can go into our space type here, and this is a predefined list of all the different space types you can think of, from schools to stadiums. You have dining rooms here, for example, and just selecting some of these, you can start to see those same data fields being populated with numbers. So if we scroll down this here, we have our air changes per hour, outdoor air per person, infiltration rates, planning lighting contributions. We have scheduling, so occupancy scheduling. So we can create some data which we can base then our design and our sort of project work off of that data on a space by space basis. Okay, so I'm going to try and find office. So down here somewhere we have office. It's the enclosed office. an area per person, 20 meters squared, sensible heat going, latent heat gain, etc., etc., etc. If I hit OK on there, you can now see some figures being added to our schedule. So let's go back to our schedule. Office. You can see a volume in here. We haven't got a specified supplier or actual supplier yet. So let's go back to our schedules, sorry, our space. We should be getting some numbers in here based on occupancy. People by space type. So let's specify there's going to be 2 people in this room. And heat gain by space type. So let's OK that. You can start to see there is some information coming through based on that space type. We'll look at that again as we start developing our project. So what we can do here, let's go back to our space schedule. There's a lot of offices, there's a lot of stairwells. Let's group these together. So let's sort by name. Let's try that, see what happens, and let's group those together. And let's add a field for count. So we can see how many there are of each room. So let's move up here. And here you can see there's 4 of this type office. And actually, let's rename these just to office to make it a little bit easier. And let's change these to stairwell. So now we have 9 offices at various levels, but we can now change the space type in one go. So let's go down to our office, enclosed office, and hit OK. You can actually create your own set of design criteria. So you can either duplicate one that's already in here, or you can create your own space type, depending on what you're trying to design. If you want to force certain design criteria through your project, use that and create your own space types. And that could then be saved in your company template for future projects to reuse. Okay, but we're going to use office enclosed. Okay, admin, again, that's kind of an office. Let's go down to office again, enclosed. We have a lobby and a lounge. So a lobby area is an open plan area. Let's find what we've got here. We've got laundry, lobby, auditorium. There's a laundry, a lobby, hotel. Let's just choose lobby for now. And lounge. Let's choose lobby again. Actually, we've got lounge recreation. Let's choose that one instead. Reception, it's kind of an office area. Reception area, library, reception, museum. I'm just going to choose office, enclosed. Stairwell. What have we got here? Stairs, inactive, stairway. So I guess stairs inactive would be an emergency staircase that really doesn't have much traffic on it, pedestrian traffic, and the stairway would be your internal stairway that would be general use between building floors. So I'm going to choose stairway. Excuse me. So we now created our spaces. We've got some space types. We have some volumes. Let's now close some inactive views, and let's go ahead and start looking at adding some ventilation, designing our ventilation system. So what we're going to do, we're going to go to our views. We're going to go into our mechanical view. And again, we've got various things on here we don't really want to see in our design. So let's turn off the planting, I think it was. And the furniture, we don't want any furniture on here. And hit apply. We kind of want some space names maybe on here. So let's go down to spaces. I think it's the reference. Right, okay. And you can see those spaces have been defined there. Let's go to annotate. Let's go to space tags, and you can see we have those spaces in there. It's actually tagged by all. Go to space tags, apply. And there we go. I'm going to change the drawing scale or the view scale down to 150. Okay, those crosses within the spaces, I'm going to turn those off. Go back down to spaces, turn those reference off. So we're going to add some ventilation grills in here now, some supply grills, and we're going to come up in the corner of the office space with our supply. So the supply is going to come down the building and feed into some of these grills. So taking the office as an example, I'm not quite sure why we've not got any flow rates in here, but let's add some in. So let's just say we need 160 litres a second of supply air into this office space. And what we can do here is you could actually export these spaces to an Excel spreadsheet format, and your mechanical designers could be populating these for you, and then you could bring these back in, or your mechanical designers could be actually within Revit and doing this straight into the software and collaborating with the rest of the BIM technicians and all the people involved in creating the project work. So you have that real sort of collaborative approach to designing straight into the software across your team. So your designer could put your flow rates into your rooms or your spaces even. So admin in here, let's put in maybe 50. Reception, let's put 50 in here. Again, I'm just making these up as I'm going along, but so lobby in here, we'd want maybe 200. In our lounge area, a much bigger area in our lounge. Let's add in here maybe 300 litres a second. Okay, we're going to add some air terminals into our office area here. So I'm going to go up to systems, air terminals, and there are a few preloaded families here. We have an extract grill, a return diffuser, supply diffuser. I'm just going to choose the out of the box supply diffuser here. I'm going to host it at about 2.4, so 2400 from level 0. And I'm going to stick one in the corner there and one in the corner here. And each one of these, this one is set to 235, this one is set to 235. The airflow rate in this office, specified supply airflow rate is 160. So let's divide that by 2. So these two grills need to be supplying 80 litres between them. So we have 80 and 80 giving us 160. Okay, let's copy the grill into here. Let's put one in the corner here. Actually, let's make it in line with the other one. Let's align those up. Move this tag out the way slightly. We're going to put another one in reception in the corner down here. These rooms are kind of smaller, so you could actually use the bigger grills with just the lower flow rate, or you could use smaller grills. We have a 600 square grill here. I'm going to change that type and duplicate that type, and I'm going to actually make that say 400. Let's go with 400. 400, and I'm going to change the face connection and bring that down to maybe 200 by 200. So the connection was 200 by 200, and my diffuser size of 400 by 400. I'm going to keep the thickness the same. So that's the thickness of the diffuser from the face of the diffuser sort of upwards to the depth, if you like, of the actual air tunnel itself. So now I've got a smaller supply air diffuser in there. I'm going to change this type to that smaller type I just created. Just noticed a spelling mistake in my space here, so reset shouldn't. Let's change that. And I'm going to add some more of these grills over, excuse me, into our lobby over here. So I'm going to put some supply air grills, maybe one here. I'm going to constrain my copies. They're in the same similar straight line. I'm going to put 2 in here. I'm going to put maybe 2 in here. And maybe sort of 1 up here. Okay, so this lobby area, I put in 200 liters a second. So my 2 grills here, I'm going to be pushing 100 liters a second through each one to make up that 200 liters supply air we're trying to specify. And over in our lounge area, we're going to specify 300. And actually, there's 3 grills. That works out quite nicely. Let's choose those 3 grills, and we're going to put 100 liters through each one. I'm going to save my project. So now we've got our spaces, our space types. We've got our supply air figures. We've added some air terminals to match. Let's just check that these terminals are actually at the right height. And as you can see, they're roughly, at ceiling height 2.4 off of level 0. So now we're going to create some duct systems. And there's a few things we can do here. We could actually just manually go along and we could specify our duct systems. We could go to systems, go to duct. We could then choose our duct style, so either oval, rectangular, or round. And these are picking up various pick list settings, if you like. So from a list of fittings, we're creating a system either using equal T's or shoe branches, for example, or press radius bend, or segmented bends. And these are just basically a list of fittings that we're collecting together as a system. So if we choose one of these types, it will use those fittings from that sort of pick list. And what's going on here is if we go down to our families in our project browser, we can see we have ducts and duct systems. Excuse me. So under ducts, you can see we have round, rectangular, and oval. So going back to our model here, if I choose duct, you can see there we have our oval, rectangular, and round. Those are those 3 types. And if I actually rename one of these, just rename this one. I just put my name on the end mark. You can see it's changing the titles of these systems. So these are just lists. These are just list headers. Okay, and each one of these has various settings, roughness for your design calculator, your velocities, and your pressure drops, etc. And other various parameters that you could populate. We have a thing called routing preferences. So that pick list that I was mentioning, you would create a list of preferred fittings. And this is the list that Revit uses to start adding to your design. So if you create some ductwork, and as you sort of turn left or right and carry on with your ductwork run, it will add a fitting, an elbow, based on what's on this list. And you can actually add lots and lots and lots of different versions of a bend, for example, an elbow, and it will go down this list and work out which is the best one based on what you have on your list. If you don't have any fittings specified in your list, it means it will error, and you can't actually then put a bend in your duct because there aren't any bends in your pick list. The same goes for T, junctions, etc., etc. You can force your ductwork to either use a T or a tap. And likewise down here, you can force it to use certain crossovers. Here we have none selected. So if there's a duct that crosses a duct, it won't put a cross type fitting in there and join those two ducts up, and so on. This also goes, this is for ductwork. The same applies for pipework as well, and cable trays. Those routing preferences, if you spend time setting these up, it'll save you a lot of time later on trying to sort of put all your duct systems together. And I'll show you in a second what that means. So let's just leave that as it is. This is completely out of the box. I'm just going to leave those settings as they are. Another thing we can do is we can go to our mechanical MEP settings here. Excuse me. Go to our mechanical settings. We have other settings along here. You can see there's that building space type dialog that I showed you earlier. But here I'm going to go to my mechanical settings, and I'm going to go to conversion here. And here we can specify some base heights that Revit uses to start adding our ductwork. So our primary main duct runs and our secondary branch runs. You can also select the service type. So I'm going to choose round press radius bend as the duct type, and my middle elevation I'm going to do as 3.3 meters. So any primary runs of duct are going to be at 300. I'm going to choose the same duct style for my secondary runs, and I'm actually going to use the same elevation for my secondary runs. So my primary runs, the main supply ducts, and then the branches off are the secondary duct runs. Excuse me. We've also got here a flexible duct type, and we have a maximum flex duct length. So we can force Revit to think about the length of our flexible duct runs. About a meter is roughly as long as you want to go. Obviously, the longer the flexible duct, the more resistance that's going to create. So now I've created those settings, I can now create a duct system. So I could actually just choose one, and I could create a duct system, or I could actually choose all of my, turn off select link. I'm going to select all of my air terminals, use my filter, I'm going to turn those off, hit OK. And I'm going to create a duct system. System type is supply. It's only picking up supply because we have supply connectors on our air terminals. And I'm going to call my system name MAN and machine supply air. Okay. Nothing seems to have happened other than now you can see this dashed box around our air terminals. And we have a few more options on our Revit MEP here. We can generate a layout, edit the system, and we can push to fabrication. We'll look at fabrication a little later, but let's just generate a layout for now. And what this does, it actually creates a placeholder system, and it joins all your air terminals together into the one system. And we have some options up here. We can edit our layout and move various duct runs around to suit. As you can see, everything stays connected. Or we can actually use solutions and get Revit to generate solutions for us. So let's change custom back to network. We also have perimeter, and you have various options in each one of those. So I'm going to just use network, But obviously these are all going to be supplied from somewhere. So there's going to be a main supply duct coming down the building to supply this network. So I'm going to choose this bottom right-hand corner as my my supply point to this level. And we can do something by placing a base. And this places a point which then Revit picks up and understands this is where the main run of ductwork is going to come down and place your system. We're going to generate a layout here. We're going to change our duct styles to round, and our base diameter is going to be, say, 200. Let's look at our solutions again. So we're going to come off from our supply duct down through here. We're going to come through back office across the reception and down onto this grill here. This might error here. This might be too short. So what I might do here is I might go into custom. Let's go back to network. I'm going to go to edit solution. And I might bring this down a little bit here. And bring this bit down as well. Might clash with the wall, but we'll see what happens. And this might throw an error here where the shoes might be too close together. It shouldn't do, but let's see what happens. Let's hit finish. And you can see Revit has now created a system, and it's thrown up an error here. It hasn't quite worked out what to do here, probably because there's not enough options in the routing preferences. And actually, it's the crossover here, look. Because we didn't have a crossover assigned within the routing preferences, it doesn't know what to do with this. So there's a few things we'll need to do here. We'll need to go to our modify tab. Let's break this up a bit. We have three, what's on? This is 200. Let's change these to 200. So all we're doing here, we're just joining ducts up. We're ignoring any design data at the moment. And that should put a shoe on there. And that should put a shoe on that side as well. All right. Let's have a look. Let's use our let's use this command instead. That says it's not attached, but actually it is. Because we're tabbing through, and everything is added. For some reason, there's something going on here. Not quite sure what's going on here. So let's pull this out a bit. Just tidy these up very quickly. Sometimes this is okay. Everything fits together quite nicely. So now we have a system put together. You can see some of the duct sizes are all over the place here and there. That's fine. What we can do now is we can actually select our duct system, and we can go to our sizing, so duct sizing. This works for pipe sizing as well, but for duct sizing, we can choose velocity, we can use friction, equal friction, static regain. I'm just going to use velocity. And I'm going to come down to 2 meters a second. You could actually use friction as well, 0.82, sort of roughly sort of 1-ish, 0.8 to 1. Or you can use one or the other to suit. So I'm just going to use velocity. So 2 meters a second. There's a few options here, calculated size, or just match connector size. So whatever duct size up to the size of the connector will be used. I'm going to use calculated size only. And you can also restrict the heights and the width. So if you've got holes in your floor slab, for example, you can't have duct that is bigger than those holes, you could force those that size criteria into here. So I'm going to turn that off for this one. I'm going to hit OK. As you can see, it's resized the ductwork. And as I said before, this grill here can't quite fit connections off of the ductwork onto that grill. And actually, this duct is huge, isn't it? Because the velocity is fairly slow, so the duct needs to be bigger. What we can do here is we can actually choose these bigger ducts, and we can do another size on here. Let's speed the duct or the air up in here. Let's change. Let's go maybe go to 3.5 liters a second. See what that does. So slightly smaller. Let's go again. Let's go to 4 liters a second. Okay, slightly smaller. So this grill here, we might need to move slightly. And actually, it has connected the duct up. That's fine. Okay, we've got a bit of an error here. The duct is overlapping the wall, so let's move this duct. Grill up a bit further. Gives us space. And actually, it's not liking that connection there for some reason. Let's leave that there for now. That's fine. There's a few strange things going on here. The duct reduces in size here. Let's pull that right back to where that airflow changes here. There's a few strange things going on here as well. Let's this one is a 560 diameter. Let's change these this duct here to 560 as well. 560. And I think what you'll find is duct is going down rather than up for some reason here. So let's look at section across here. As you can see, the duct is going down rather than up. So let's just delete here. Turn that duct around, join it, go up building instead. And you can see it's just below the slab level. You can see the person sat here on the sofa in the lounge area. That's worked out quite nicely there. Okay, so now we have our ducts. We can do other things with this as well. You can look at our system and inspect what's going on. So this allows us to sort of zoom into various areas of the duct. And you can see here, look, we've got a flow rate of 440 liters a second. There's a static pressure of 26.4, and there's a pressure loss of 0.5 per meter length in pascals. And as you go around the model, you can see this section sort of a lower flow rate. It's just supplying the one grill. So this is the metadata. This is the enriched data that's being stored in a database in your model. And this is the information that we're using to design straight into software. And you can see we have our primary index run, this red one here, and flow arrows here. So you can see the direction of airflow with these arrows on our ductwork as well. And this information that is in this this sort of tag here, you can use this information to look into your project work and look into your design. But as soon as you finish that command, that information disappears again. It's still there in the background. So what we do, we could tag our ductwork to show that information. So let's go to annotate and tag. And here you can see we have a duct size 560. If I could tag on this one, you have a duct size of 250. We don't want to go around and click on every single duct, so let's delete those. Let's go to annotate and tag all, and let's go to duct tags, which can use a duct size tag. We're going to apply. Now, as you can see, it's added those sizes all the way around our model straight away. And if we change a duct size, so if we do another calculation, and for example, we change the duct size and it threw up a different duct size, say 400, that tag would change, and that information, that data is being drawn upon to populate that tag. So these tags, I don't know, picking that one up, or I want that one. I just want to copy that one. No. Thanks, back on again. These tags are just picking up the duct size. So if I edit this family, it's just picking up a label on size. What we could do here, we could actually add a lot more information. So we can add the flow rate, add friction, anything to do with this, this duct. We have the length of the duct. This is all information that we're picking off the database that's going on behind. We pick up the size there. We've already got size in our list here. System name, type, classification. Let's do abbreviation, system abbreviation, and velocity. And let's add some breaks here so it tabulates, or it puts those items in a list for us like that. It's a bit of a long tag. Let's just pull this out a little bit. But let's just show you what you can do with this information. So now we're reporting on each piece of ductwork, and you can see all that information being added as tags all the way around. Okay, it's a bit messy. A bit messy. We can go around and tidy these up a little bit. Let's pull that one across there, etc., etc. So that's level 0. That's a supply air duct system. There's a few things we can do here. Let's create another view from that view. So let's duplicate that view, and let's rename this to velocity. Duplicate this view again, and let's rename this to volume. What I'm going to do here is I'm going to add some color fills. So these are going to be a visual representation of what's going on in this design using a legend and some color fills. If I go to annotate and duct legend, and let's just put this down here at the bottom. And we're going to use, this is volume. So this is the flow rate, so duct color fill on flow. And what this is doing is picking up the flow rate in our ductwork, and it's assigning colors and a legend to that view. So straight away, 80 liters a second, those 3 lengths of duct are at 80 liters a second. Let's do the same for velocity. Again, let's go to annotate, duct legend over here somewhere. And this time we're going to use velocity. We're going to hit OK. And you can see everything is less than 4 meters a second, because we had we set that to 4 meters a second in the main duct. We can actually then click on this. We can edit this scheme. Let's add in here 2 meters a second, 1 meter a second. We know we haven't got some of the larger velocities, so let's take that down. So now we should start seeing some more colors, and here we are. Got 1 to 2 meters a second. The gray is 2 to 4 meters a second. So if we had various different velocities, here you can see there's a slightly slower one, 0.5 to 1 meter a second. Let's go down a bit further. Let's edit this scheme even further. See by value. There we go. So those are the actual values. Our ductwork. So 0.6, 1.1, 1.4, etc., etc. So you can show the actual values, or you can show ranges of those values. Okay. Another thing to note on this type of designing is if you were to break your ductwork. So as an example, let's Let's go to modify it. Let's break this ductwork here and here. It's actually not the outcome I was expecting. Let's go to our volume instead. If I was to delete a section, try and break one of these over here, what should happen is it should error, say there's no airflow in here because there's an open end. Try that again. Duct sizing 4 meters. Okay, what this should be showing us is this should error the airflow. There's an open part of some duct, and the airflow isn't coming through properly. So let's try again. Let's break it here, see what happens. Yes, there you go. So we have zero flow in this bit of duct because we're not picking up any air from the system because there's an open end to the system here. And the point here is sometimes when your designers or your BIM technicians, they are modeling their ductwork or their systems, they're not quite connecting ductwork properly. So let's, if I delete this here, so maybe if we did this, you can see it looks like it's a duct system, but actually we have zero flow in our duct here. And if we didn't have a color fill legend like this, if we just went back to our zero mechanical drawing, you wouldn't know any different other than the fact that these figures are showing up zero. So there's another quick way of looking at how our systems are put together. So what we can do here, we can go into a 3D view, we can turn everything off, just have our ducts turned on. Rotations, turn everything off there. And flexible ducts, turn those on. Ducts, flexible ducts. And what we kind of do here is we can go into our filters and we can add a filter. So let's just create a new filter. We're going to choose duct flow. We're just going to call it duct flow. So this is a check to see where the breaks in our systems are. So let's go down here. Let's go down to ducts. Add a rule in here. The dialog box hasn't quite stretched properly. So we're going to add a rule to ducts, and we're going to base that on flow, and is less than, I'm just going to put a very small amount in there, so 001, and we're going to OK that. So where's that flow, duct flow, OK that, and we're going to add a pattern, solid fill pattern, and we're going to color that in red. And I'm going to hit OK. And here you can see now that flow, that ductwork connection there, it's not quite connected. There's zero flow. You can see straight away where the problem is in your model. You can see there's no flow coming through this fitting, and actually going through here, you can see now that's not actually connected properly. So let's pull this back. Let's delete that bend, and then let's connect this to this. Now we have our flow again. And you could actually add another filter. Duct flow. Let's duplicate that filter name. So duct flow green. Let's call that one green. So duct flow is greater than 0.001. Okay, that. And let's change that pattern to green. So green. There you go. So now you can see we have airflow. I pull this apart. Oh, that should change to red. Why is that not changed to red? Filters. Duct flow, edit. There we go. So you can see where your system is erroring. Very quick way of checking your system throughout your building all the way through. And again, you could save that as a, let's rename the view down here. We can call that duct flow check. Oops, duct flow check. And you could add or create a template from there. So duct flow check, duct flow check. And then apply that template to any other views you have. Okay. Very quickly, let's look at some drawing sheets and put these views onto some drawing sheets. So we have an A1 metric as a base template out of the box with AutoCAD. What we can do here is, it's called it A101 unnamed. Let's rename this. Let's call this sort of M001. Let's just call this mechanical services level 1. And let's actually call it level 0. We started on level 0, didn't we? It's level 0. And let's drag our level 0 mechanical view onto that drawing. Okay, so we now have a view of level 0 on a drawing sheet. So we could go ahead and we could create some more drawing sheets. We could go into our sheets, we could right click, we could do a new sheet, etc., etc. There's actually a quicker way of creating drawing sheets without using any add-ins or you know, any sort of tools, any plugins. You could actually just create a new sheet list. And we put a number in here. So let's change the sheets, show sheet name, sheet number, and various other information here, designed by, drawn by, etc., etc. I'm just going to use a sheet name number, designed by, drawn by. If I hit OK, there's that drawing sheet that I've just created, level 0, M001. If I go up to the top here, I can actually insert a data row, and you can see it's adding a drawing number as I go down. And actually, I could go down here and I can just very quickly add some names as well. So 01, 02. Let's add mechanical services. Let's do, I think I did a section. Let's add a section. Oops. And then we had mechanical services, I don't know, volume, and velocity. So velocity. So this, what is done? It hasn't actually created drawing sheets as such. So if you look down to our sheets in our project browser, you can still see that one drawing sheet in there. What it's done, it's created placeholders for those sheets. So it's used M001 as a start point, and it's gone up in increments. I've added those data rows into a schedule. And what it's done now is, if we go to sheets and new sheet, it's added those as placeholders in our new sheet dialog. And I can actually select all those in one go I can choose my drawing frame. So we've only got an A1 metric here, but you can use whatever type of block you have. Hit OK. And then those drawing sheets are all created straight away. And each one has got a title and a drawing number. The font size isn't great on this example title frame, but it gives you an idea of how quickly you can create these drawings. So level 1, we can bring in level 1, mechanical, etc. Let's go down to our mechanical services volume drawing, and let's bring on that volume on there. Let's go down to velocity, and let's put our velocity view on that drawing as well. And one cool thing about Revit 2023, it's a new feature that came in our views in our project browser. We have this box next to our view names. So any views that are put onto our drawing sheet, we have a blue filled in box showing us that those views are actually on a drawing sheet. So you can see views not on sheets here. That was a feature that's only just come into this version, which is really good. Another great thing of Revit 2023 is you can duplicate drawing sheets as well. So we can right click, we can duplicate sheets, same way as we duplicate views. And you can actually duplicate with the views as well. So here you can see I've duplicated that velocity. I've got a copy, and I've also got a copy of the view. So we go up to our views up here. You can see it's created a copy. And you could actually now select that view, and you can actually change that view to another view. So let's say zero ceiling mechanical, and it will swap that view out and put that other view in. So another quick way of adding information, adding drawing sheets and views into your project. There was a section view that I did. So let's go to our section drawing. Let's go down to our sections down here somewhere. Spaces, ceilings. I think it's under here, sections. Here we go, section 1. Let's just bring that in. Let's apply the mechanical template to that view, mechanical section. It's a bit small and actually hasn't changed much in the settings, but it gives you an idea of what we can achieve here. Let's go into the template. Just quickly change that. So mechanical section. Let's go to the graphics. We don't want furniture. Turn the furniture off, and I think it's planting. And here somewhere. Planting. So okay, that. Let's change the scale of the view as well. Let's change the 1 to 50. A little bit better. And so finally, I know time's getting on a bit now. Let's save this project. Finally, you'd want to push your design into some sort of fabrication package ready to go to your duct fitters, etc. My advice here would be to, before going into your fabrication function here, is to save your model into another version to use as your fabrication model. And the reason is when you change your duct systems using the fabrication parts, it tends to lose the data based on flow rates and velocities, etc., etc. You'll lose your color fields, and you'll lose your 3D drawing with your flow check. It won't be able to pick up that data. That data is lost in the fabrication process. So what I'm going to do here is I'm going to save this project as a fabrication model. I'm just going to call it fabrication. And now if I go back into my level 0 plan, I'm going to close all my inactive views. I'm going to turn my tags off as well. Actually, I'm going to leave those on and see what happens. I'm going to go to fabrication. So under systems, fabrication, and I'm going to load my parts library. So we have fabrication configurations, we have metric and imperial, and go to metric. We have all sorts of systems in here, electrical, piping. These are based on actual off-the-shelf fittings and criteria. So let's just choose ductwork 250 PA. This is going to bring in some slip jointed round ductwork, for example, and all the fittings associated with that. Try again, content, parts, connection, code configuration. I forgot to add it to my list on the right here. There we go. So now we've loaded in all of those fabrication parts. We can select our duct system. And we've got this design to fabrication. So this is going to convert our Revit duct system, and it's going to replace all of those fittings with actual fabrication parts. Here you can see on the right, it's picked up the various sizes of duct and what those sizes are. So let's choose finish. And there's a few errors here. It was that problem fitting here. The part, the Revit fitting wasn't big enough. So let's just disconnect that one. And what we would do here, we would actually maybe pull this back a bit. Whoops. Try and connect that onto there. There we go. And as you can see, we have now more sort of real world duct fittings. And they're all joined together, creating our duct system. Let's go to our 3D view. And you can see now that the ducts have disappeared. This is because it's changed the Revit category. It's changed it from duct, which is a Revit category, to I think it's MEP fabrication duct. So if I now go into my visibility graphics, you can see ducts are still turned on, but down here now, MEP fabrication ductwork. It's changed the category of the duct. And you can see now the value that it's using to show you the airflow rate disappeared. We haven't got any flow rate figures now in our ductwork. This is now a fabrication object, and you can see now we've got a weight, we've got the material specification, the size, etc., etc. And we would push this fabrication information to a manufacturer to then create those parts. One last thing we can do here, we can optimize the lengths of the ducts. So we can select all of our ducts. Let's turn off duct fittings and flexible ducts. And we can do something here, we can optimize the lengths. And this actually uses set length of ductwork. So if it's spiral ductwork, it could be 3 meters long or 1500 meters or 1500 millimeters long. It will actually cut those ducts and optimize your sort of pick list for that job. Let's use optimize length, and you can see it's broken down those lengths into equal parts, ready to be quantified and manufactured. We go to our schedule, our schedules, so our velocities. Again, you can see that color fill has disappeared because the data isn't there anymore for that filter to work. But you can still see the color on the flexible ducts. Those fabrication parts aren't part of this fabrication library. And actually, I don't think you can use fabrication to do those particular bits. And you can see here, there's a bit of an error here as well. We can't add this duct in here because there is a problem with this T-piece in the way. There's no physical sort of space to put a fitting on there. So there's a few things here you have to go around and tidy up using your parts. And maybe here, look, you would move this fitting maybe inboard a bit, and actually only need a smaller hole through the wall there then. And similarly here, you might need to do something here to make this sort of hole through the wall a little bit easier to use. Another thing that's slightly frustrating with fabrication parts is they don't actually populate automatically with a mark figure. But they do have something called an item number. But again, this item number isn't populated automatically. So you'd have to use something like Dynamo or a plugin to actually add that information in. You could actually schedule this information. So let's go to our schedules. Let's create a new schedule. Let's go to MEP Fabrication, ductwork. Here you can see that category, MEP Fabrication ductwork, and all the things that are available. So we have count, we have description, we could have, for example, if there's any fabrication notes, service name, there's a size, and there's that item number. It's not automatically populated. So, and then we have mark as well, which hasn't got a value in that. Let's choose that size there, and let's remove that free size there, and let's hit OK. So these are all the part numbers and lengths. Let's add some more fields in here. Let's look at family, and let's look at type as well. Type down here. And we have weights. So ductwork weights as an example. And you can see there's a lot more information coming through here. We have the weights of the various parts. We have the families, we have round pipe, spiral pipe, we have T's, etc. And we could actually condense this list down by using a sort. So let's sort on family type, maybe, or just family. And we could do grand total and OK with that. So now you've got down here, we've got 10 round coupling fittings. And we have some spiral pipe here. We have 19 sections of spiral pipe. And we can do some more things here. We could change by family, I think it was, and then length maybe. So we have some spiral pipe here with various lengths. So you can use the schedules to create various combinations of the information you're trying to pull out of your model. This enriched data that's part of your model. Okay, so that's Revit MEP. I hope I hope you found something useful out of this session. I'm sorry it's been a bit longer. It's been almost an hour and a half. If you've got any questions, please get in touch with me at Man and Machine. So mark.pettit@manandmachine.co.uk. We've got lots of other webinar videos that we've got on our YouTube channel. We've got a blog on our homepage. Take a look through there. If you've got questions on this or anything, or you can't find any answers in our blogs or in our video logs, or vlogs even, please get in touch and we'll do our best to help you answer your query. And with that, I will say goodbye and thank you very much for watching.